All right, we're live. So hello everybody, welcome to TST meeting. Today we have we're gonna have a presentation from IPInfusion from Tetsuya. But before we cover that, let's delve into some of the preliminaries, specifically starting with some community shout outs from David.
Great, thanks. I don't know if you have a chance to pull up the acknowledgements page, but I had mentioned at the last TST about the recent boot camp and hackathon in Beijing, and I didn't have names to share then, but I do have the names now on that wiki page about the winners, the top 3 teams that won the hackathon event. So just again to give a shout out to the specific people who won, they did a great job. Everybody was really impressed. You know, all the teams did a great job, and all the teams, I think at least 1 or 2 people from every team pulled an all-nighter, but these were the 3 that really stood out, and they won the event. So just to give them a shout out, we've added their names to the acknowledgements page.
So Dave, do you want to talk a little bit about what their projects were? I'm getting some echo from the room, but yeah.
Sure. I think Bob was asking what the projects were in Madon.
What the projects were and why you thought they were particularly cool.
So actually, the projects themselves were a set of pre-prepared questions that were given to them, and they could pick one of them. And so these are actually quite familiar for us because we have been doing different versions of these applications before, but this was a group of people who are looking at ONOS for the first time. So for a lot of these people, these are new questions.
There's a whole lot of background noise, so it's kind of hard to hear you. There are a lot of people kicking the table and shuffling papers around and talking in the background, so I can't hear you, Madan.
Yeah. So can you hear me now?
Yes.
Okay. So in this particular hackathon, the format was that the participants were presented a set of 6 questions, and these are basically, each of them is, develop an app which does a specific piece of functionality, and they could select one of them, and the questions were rated, low or beginner, medium, and advanced in terms of Hello. Basically they selected one of the questions to work on, and the aim was to write an application that demonstrates the set functionality, and also do a presentation on what how they implemented it, what lessons they learned, and things and so on. So the questions themselves were, I would say, for people who have been working on ONOS for a while, are probably not very difficult, but this was a group of people who were looking at ONOS for the first time. So I think that was the difficulty in this.
Great, thanks.
Okay, so we're waiting just a little bit for Tetsuya to get online. I think we should be ready.
Looks like he's online.
Okay, cool. So what you can probably do is
be sharing the screen if you go to the Hangout.
Okay. Perfect. Okay, sounds good. Yeah, welcome. Thanks for coming, by the way.
Thank you.
So recently, we have several customers who are very interested in the ONOS. So, however, they would like to achieve the existing networking functions on top of the OpenFlow switches. So, for example, some customers require the OSPF and the LDP and the multicast as well. And also, some customers would like to achieve the eVPN, the VPNs, VPWS service, and also MPLS VPN, including the VPN v4 and the VPN v6. So currently, they know the ONOS about the SDN IP solutions. So they would like to separate the control plane from the user plane. So control plane is running outside of the network. And then, so control plane, based on the control plane information, so they would like to provision the flow entries, flow mode to the OpenFlow switch to achieve the embedded VPN service with LSPBWS service, all services. So currently, so I think so current SDN IP model is relying on the BGP. So in case of the BGP, BGP does not require any interface information. However, in order to run the OSPF, OSPF needs the interface information because the OSPF calculating the topology based on the SPF calculation. And also in case of the multicast, so multicast requires the interface information as well because they need to do the reverse pass forward. So as per my chat with the customers, they are assuming Atrium Open SDN distributions. So they are thinking to add the control plane application as a SDN applications. So this is their motivations. So they would like to achieve the huge routers. So this huge router consists of the several hardware. So based on the number of subscribers, so they can increase scale out the such a huge routers. And if the number of subscribers is increased, in this case they can scale down. So just to simply removing the OpenFlow switches. So currently in this figure, 3 OpenFlow switches present. So green one is the internal port. So each OpenFlow switch is connected to the green port. And also red one is the external port. So existing IP router is connecting to the external port. So based on this, they would like to provide a VPN service on any other services. So however, so it is very difficult to add any routing protocol, signaling protocol on top of the OpenFlow switches. So we are assuming to use our control plane, which is running outside of the actual network. So my idea is ONOS is managing the internal port factory, and then ONOS providing the virtual instance. And also ONOS is managing the mapping between the virtual instance and the physical instance. Control plane is just running on the virtual instance only. So right now, I'm assuming to use our ONOS product for the control plane. However, so any application can be run on top of the virtual router, I think. So for example, any SDN controller such as the View and the OpenDaylight can be running on the virtual router. So such application just controlling the virtual router, not physical switches. So ONOS is controlling the physical switches based on the virtual router information. So and also, as I mentioned here, in order to run the VPN V4 and the VPN V6 and the OSPF and the multicast applications, control plane need to know the interface information. So right now, so our boundary can support to create a pseudo interface inside of the boundary image. So such as each pseudo interface is mapped to the external directory. For example, ONOS can create a virtual router which has the only external port. Internal port is perfectly hidden. So because the internal connection can be managed by the ONOS perfectly. So only external port is exposed to the by using a virtual instance. And then I'm assuming to use the OpenFlow channel between the application and the virtual router instance. So based on the OpenFlow channel, so our application can get the port information by using a port description message, and then based on this message, automatically pseudo interface is created. So each pseudo interface is mapped to the virtual interface having a virtual interface, virtual routers, and then ONOS can manage such a virtual port to the physical port. And also, the customer is thinking to manage a multiple virtual router by using a single ONOS instance. So, for example, in this case, two OpenFlow switches on the left side is mapped to the single virtual instance. Another two OpenFlow switches is mapped to the second virtual instance. And each application is running on the each virtual instance. So, for example, left side is taking care of the any control plane and the networking service on top of the virtual instance number one. And second one is taking care of the such a networking function on top of the virtual instance two. And also, this slide is a little bit detailed. So, in order to run the virtual instance, in order to run the control plane application separately from the physical network. So, as I mentioned here, this guy needs to know the interface information. And also, when getting the packet, let's say multi-host packet or any control packet, this guy needs to know which interface such a packet is coming. For this, my proposal is to use the packet in, packet out operations. So ONOS can track the any control packet via packet in, and then this packet information is based on the physical information. So, however, our application does not know the physical information. So I'm expecting the ONOS to translate from the physical information to the virtual information, and then our application can run the virtual information. So the reason why to use the OpenFlow protocol between the ONOS and the applications, so OpenFlow can have a definition to trap the packet. And also, OpenFlow can provide the fault information as well. And also, OpenFlow is the standard protocol, not proprietary protocol. So this is my idea. Yeah, so this is a more detail. Yeah. Any questions so far?
So would you imagine that in your virtual switch, the virtual router that's exposed to ONOS, that would be dynamically scaled?
With a velocity?
So you have one giant switch, basically.
Yes, yes.
Let's talk about this in OpenFlow terms. Look at the router. Can I dynamically add ports? Can I scale it and grow it and shrink it dynamically?
Yes.
Yeah,
but our product is blue one, so velocity. So I'm expecting ONOS can support such a virtual instance functions.
The only, well, I mean, from my point of view, I know there's other opinions here, but from my point of view, the only limitation of such an approach is using packet in and packet out for transporting the control messages.
Yeah.
That's going to, the problem isn't with the protocol, the problem is with the hardware switches, which kind of choke after a while if you ask them to, because once you install a lot of flows on them, when you query for flows, the agent is busy, and basically if you get a control message at that same moment, the control message is queued behind all the stats you have, and you can lose your connection, your so for example,
Yeah, to follow up on it, this is sort of an annoying problem with OpenFlow, which is that it doesn't by default do data plane packet-ins, or if you forward packets over the data plane, you lose the ingress port, so you end up having to burn a bunch of extra OpenFlow roles to if you want to maintain the ingress port information. But I sort of, I mean, in contrast to what Ali's saying, if you look at how chassis switches tend to work, they don't have a lot of bandwidth usually between the control plane and the data plane, and there is this head-of-line blocking problem that Ali is talking about, but I think that that's mainly on a per-switch basis, and so you sort of have that problem in many sort of physical chassis switches anyway. So I'm not sure it's an insurmountable issue.
I don't think it's insurmountable either. It's just something you have to be aware of, because it'll cause your adjacencies to disassemble at the worst time possible. Right? Like typically when you've established all your routes, and all of a sudden everything melts away. Right?
Yeah, it tends to fail under load. That's why if you can avoid, sort of mounting a denial of service attack against your own controller through the control channel, and just forward, other random control packets from whatever they may be, ISIS, OSPF, MPLS, whatever weird random control packets you have to deal with, forward them over the data plane to another agent. It might be a more robust solution.
Yeah, that comes at its own cost as well, anyway.
Yeah, my question is sort of relating to sort of ONOS versus OVX. I'm getting a lot of feedback from the room, so it's hard for me to talk, kind of echo. But it seems that this is something that OVX can sort of do, except for the dynamic aspect that Ali was talking about, where you dynamically add ports and switches. I think that ONOS or OVS is the right platform, and also this is also something similar to what Thomas was talking about. That if you add virtualization capabilities to ONOS, where you can create a big switch, maybe we can do this already if we implement that suggested project.
What was the question?
The question is, is it necessary to have this as a separate application if you either have OVX, which already has the capability of creating big switches, or if you have the proposal that Thomas had of allowing ONOS to create big switches based on physical switches. It looks like it's sort of the same thing, and that could be plugged into your control plane without having to add additional sort of functionality to ONOS, either beyond what Thomas proposed, or maybe not even use ONOS at all. If you're going to use Rio or Open Daylight, that means you have an OpenFlow northbound. So maybe in that case you either need to implement an OpenFlow northbound in Thomas's virtualization solution, or you need to use something like OVX that supports an OpenFlow northbound already.
Yeah, and the issue with OVX in this scenario is that it's not robust enough to actually go and support some products, right? OVX itself will need a lot of work to bring it up to the level that's expected.
I can't speak as to the maturity of the OVX code, or how scalable it is to huge numbers of ports, but it seems to me that the approach is certainly applicable.
Yes, so it is important to achieve the high scale virtual routers, virtual switches, but the other aspect is our customer would like to use the existing networking services on top of the such as 4G. So for this, networking protocol is required. So multicast requires some protocol PIN and the IGMP MLD, and also MPLS VPN requires the VRF terminology and the isolation of the each customers. So
I understand. I think that's clear, Tetsuya. If I could ask my question maybe a little bit more clearly, how does this compare to the big switch, to the other big switch solutions which have been proposed that we've seen so far? So we've seen that Open Vertex has the capability of creating big switches and has an OpenFlow northbound protocol, right? And also Thomas proposed a system in ONOS where ONOS would be able to create big switches, and that could be used as well. So what are your thoughts on how your proposal is different from sort of Thomas's proposal that creates big switches, or Open Vertex, which also creates big switches? Besides the control plane is obviously different.
But you're not suggesting. I think, Bob, there's a bit of a misunderstanding. You're not suggesting implementing the ONOS part.
Yes.
You are or you're not? You are or you're not?
We are not working on the ONOS side.
Okay.
Yeah.
Okay.
So
you expect ONOS to be able to do this?
So I'm expecting.
Oh, I see. Okay. Yeah. So in that case, I guess the question is it necessary to use OpenFlow as the northbound protocol, or could you just use the regular ONOS APIs for virtualization that Thomas has proposed?
Yeah, so I think OpenFlow between the ONOS and the application is not mandatory. So if you have any alternative solution, it should be okay. But we have to get the control packet based on the so which control packet is needed is decided by the protocol. So OSPF has a different loop, and also BGP has a different loop. So based on this, we need to get the information packet for the any control protocol.
For sure. Well, you know, as we know, OpenFlow is very good at telling packets where to go in your network.
Yeah.
So if you want, so clearly ONOS's existing APIs, you know, things like flow objectives and flow rules are certainly capable of recognizing any packet you like and sending it wherever you like. So certainly that is a capability that would be supported. And I guess my other question for you is, if you did go with the OpenFlow northbound, would you potentially be able to run this either on hardware, either on a large OpenFlow chassis switch, or on OpenVertex, configuring a number of switches into an OpenFlow big switch?
Oh, sorry.
So the question was, is one of the reasons for using OpenFlow north of ONOS so that you could potentially swap out and use a big hardware switch directly, or use a different control platform like OVX?
So the motivation to use the OpenFlow between the virtual router and the application is to because the OpenFlow has enough definition to achieve the this model. So for example, packet in packet out can be useful for tracking the control packet and also for sending out the packet, and also any routing MPLS information can be given to the ONOS by using a metadata or some other thing. So of course, if ONOS API can achieve the similar features, so in this case, I think it's okay to use the ONOS API. So
yeah, I think so too. But as I was trying to point out, if you use OpenFlow, then you would have the interesting capability of either running directly on hardware. That is to say, you could use a large chassis OpenFlow switch, for example, hardware, or you could also run against OpenVertex, which would also be kind of interesting. So that's one perhaps advantage of using OpenFlow as your northbound protocol, is that, I mean, that is the advantage of using OpenFlow, of doing protocol level virtualization, is that you can run seamlessly across a network operating system like ONOS if it has an OF northbound, physical hardware if it has an OpenFlow interface, or virtual hardware virtualized by something like OVX or FlowVisor, sliced by FlowVisor, say, that also has an OpenFlow northbound interface. So that's kind of the advantage that I'm trying to articulate. I think Brian was articulating as well, a potential advantage of using OpenFlow as your northbound protocol. On the other hand, I think it's very clear that the ONOS virtualization API should be rich enough to support whatever functionality you require for this application.
Yeah. So I'm thinking the ONOS is fully manage the physical switches as well as the internal connectivities, and also I'm expecting the ONOS to provide the huge virtual switches. So on top of the such as huge virtual switches, so any applications, I'm expecting to have any applications such as the protocol. For this, so ONOS is, I'm expecting the ONOS to simulating the virtual hardware switches, virtual switches supporting the OpenFlow protocol.
So the control plane for the router is running in Vernos?
Oh yes. So any control plane, BGP, OSPF, everything is running inside of the Vernos. Yeah.
So could you tell us a little bit about what Vernos is as a platform?
No, Banos is a VM image. So it's run on the KVM and the VMware.
It's just a controller.
Just controller, yes. So there is no packet forwarding functions.
Okay.
So Banos is on top of the Banos control plane is running. So any control packet tracked by the switches in this figure ONOS. So such a packet is going to the corresponding protocol. And then
okay, I understand then. So this is very interesting. So another reason you might have to use OpenFlow is that rather than the ONOS APIs, that we currently don't have sort of a high-performance off-platform API for ONOS, right? We have things like you know, REST and Java RMI, you know, which probably can't easily call from C. We don't have like, you know, gRPC or shared memory or some kind of high-performance off-platform interface. So that would be another reason to use OpenFlow, if I understand you correctly, which is that your application's not actually running as in the ONOS kernel and the ONOS JVM. It's actually running off-platform in some other VM in this other sort of environment. And so you need a way to communicate potentially over the network, or at least certainly to another process, to basically make calls into ONOS. And so one obvious interface would be OpenFlow. Another would be implementing some sort of high-performance kind of RPC interface to ONOS.
Yeah, so because I'm expecting to eliminate any limitation of the where Banos and the ONOS is running. So any place should be fine. So only requirement is the IP connectivity between the Banos and the ONOS. So in this case, Banos does not have does not require any connectivity to the OpenFlow switches. Banos just requiring the IP connectivity to the ONOS. So in this case, we can eliminate any limitation, physical limitation, where Banos and the ONOS is running. And also, yeah, in this figure, so yeah, in this figure, so I'm expecting the ONOS is simulating the multiple virtual instance at the same time. So at the time, so our Banos control plane application is running separately to manage the virtual instance. So for this, I'm expecting to run our control plane application separately from the ONOS physically. So for example, I'm assuming to run such a control plane application on top of the VM and the VMware as a virtual machine.
To me, I mean, I obviously don't mind the OpenFlow channel because it's been my bread and butter for many years. But I think this is great, because the ability to build routers with, like, you know, support for BGP, MPLS, VPNs, and whatnot, right? And be able to scale them dynamically. Just like I add a line card nowadays into a chassis, is something that, like, is, I mean, like, service providers will eat this up. Like they will immediately, because being able to scale their routers without having to go buy a $500,000 piece of equipment again is I mean, there's nothing better than that, right?
Yeah, I agree. I agree with Ali. I think it's a killer app. Like, I mean, I used to work at a switch company where we build these huge chassis switches, and the problem is that you have this huge capital outlay at the beginning. In fact, but because you're afraid, you want to have room for growth for putting in extra line cards. But if you look at them in the field, most of them are only partially populated. So the idea of, you know, instead of, it's similarly to, you know, kind of the supercomputer era, where you can either buy big iron servers, which you can still buy, or you can buy a cluster of PCs and sort of have, which are kind of cheap, and you can sort of build incrementally and sort of use them as your supercomputing or your kind of enterprise or high performance computing platform. So I think it's a really good idea, even if it's you know, kind of boring to me because it's sort of, you know, sticking in this legacy world. But I do think it's potentially kind of a killer app for OpenFlow, really, that people can basically, I mean, the idea of kind of scalable networking hardware where you just put in more white box switches and you combine them into a huge virtual router. assuming you can make that work, I think that would be, it is an interesting and cool application.
Yeah.
I mean, I don't have any problem with that. One question I have is in here: would be getting along with semantics of ONO, or would that be predicated on something as with some of the maybe more contemporary constructs like 1.3 or 1.5?
So the question really is OpenFlow channel to the north of ONOS. What version of OpenFlow would you expect?
I don't have any preference here. So maybe latest.
You need to support MPLS.
Yeah, we are supporting
At
MPLS.
least 1.3.
Yeah, so latest version should be fine. Yeah, because latest version can support the MPLS as well. Yeah.
That was nice.
That doesn't actually. So
yeah, that's right.
It's a big virtual table.
Yeah, I know, but my question was specific: is if there is no need for multiple tables, then actually that would simplify the problem.
Yeah,
You could still use the language of free, but with some modified semantics, right? If you're dealing with very simple pipeline.
Yeah, I think you can give it a little bit more thought than whether you want multiple tables just to limit the number of flow rules you send.
Sure.
So for the card
That would be, yes.
That happens, but
I think a single OpenFlow table could map onto an intent. And then the intent framework would deal with sort of within the frameworks. Because like you don't have a single table applied to its magic, which is stuff that's able to like run a tend or a
it's the amount of reactivity you need, like how quickly do you want to react to physical events in your virtual network, right?
Right.
So if you want to be able to propagate them or not, because that's like another parameter of a virtual network.
like links are down inside the network.
Yeah, for example, in some cases, right, like typically if you mention the backplane of your chassis, right, is the actual network you have. Right? If a link goes down in that chassis, right, you have options. Some people who deploy a virtual network will say, well, I want to be notified of that error, right? Other people say, I don't care, I don't want to know, right? I just want to, as long as it can work, I want it to work. Right? So it depends on like tastes and what people want. But
it looks like in this model that the ONOS virtual router would be responsible for maintaining links and would not propagate a failure north as long as it could sort of meet whatever its requirements were.
choice, right?
Yeah. So my question was maybe to John. So the existing routing application that's existing with ONOS could be adapted basically to work with this, right?
This kind of sidesteps it because the decision about like the forwarding happens up in the ONOS, right?
Okay.
ONOS just pushes I suppose it's like a big switch to the ONOS. So ONOS doesn't really know what it's doing. It's just being told to do something and it doesn't.
No why? Okay.
So I sort of have another question, I guess. This is perhaps more for Thomas or Ali. And that is, for your virtual routers, you might want to have very large routing tables. And we have this rib that's shown in the Vernos C. And the question is, how much of that routing information is stored in the physical switch flow tables? And also, sort of how large or what kind of flow table is created by ONOS? I'm still getting a lot of feedback, so it's hard for me to talk. But sort of, how does ONOS manage its virtual flow table for the virtual switch? How big is it? What can it match? How's that configured? Sort of, have you guys thought about that? And also for Ali, like, how does that work with OVX when you create a big switch? Like, how many flow table entries does it get?
I mean, the big switch itself, the virtual entity, has an infinite amount of flow entries. Now, whether you program the hardware switch with that, it's a different story, right?
Yeah, so you're saying it basically works sort of like OVX, that the switches just have perhaps some sort of most recently used or least recently used cache, basically a flow information, and it's sort of updated dynamically. Is that sort of how it works in the the virtual router has an infinite flow table that just has all the information. Is that correct?
In OVX, we never went down that route. We assumed that like we had essentially pseudo tunnels through the network which created our virtual, which created the topology of our virtual network, and then we mapped traffic into that. So we were leveraging soft switches that are super large flow tables to allow us to map a lot of traffic and a lot of flow rules into the network, all of rules into the network. But you'll run into that issue when you play in the real world, where especially if you're doing routing, the hardware switches you pick will be
So
annoying.
I think the scalability and performance on the of the hardware depends on the hardware spec as well. So, however, and also required performance and the scalability it depends on the use case. For example, in case of the MPLS VPN, normally carriers require the tons of routing entry, 1 million or something. So from control plane perspective, our bounds can support over 1 million entries. So however, sometimes hardware switches has a limitation of the control. So in this case, in this model, I think normally in case of the MPLS VPN, one port is connecting to the only customer, normally one customer. So because each port is logically isolated by using BRF. So if increasing the number of customers, so this means the total number of routing entries increased. So in this case, I think it is possible to stack the additional physical switches to increase the flow entry. For example, so normally, so in the MPLS VPN, so one port is connecting to the one customer. So normally, carrier limits the maximum number of entry per of the single customers. Let's say 100 routing entry. But the total number of the customer is getting bigger. In this case, total number of entry is getting bigger. However, at the time, so more interface is required. So I think it is possible to apply the scalars by stacking the physical switches. However, even those hardware switches increase, so from control perspective, operator's perspective, they are managing the single virtual instance only.
If I can get a feedback, so it's really hard for me to.
You try this.
Okay, that's better. The echo went away. So yeah, I mean, I think what you're getting at, which I think is really a powerful idea, is that if you're willing to, take a penalty of more hops, you can actually get more flow tables and get multiple tables by simply running through multiple OpenFlow switches. By creating a hierarchical topology, and that can be used for a couple of interesting things. One, it can be used for multiple tables. Two, it can be used for sort of ganging the tables together to act as a single table. And I guess three, it can be used for hierarchical routing. So for example, you could have multiple tables, each of which looks at part of an address, or each of which, or you could have things, as I think Tetsuya also said, sort of segmented by customer. And so the customers could be limited, for example, to the number of, or the tenants could be limited to the number of routes that they would have. But the system as a whole could still process many, many routes through its core. So those are all kind of interesting ideas. I mean, the sort of interesting thing about building a virtual router is you can potentially control its topology, and by using sort of hierarchy and multiple hops, you can sort of pay more latency but get more processing and more flow table space, and also multiple tables, et cetera, by ganging switches together. So I think it's a powerful idea, but there is a cost, and the cost, of course, is running through multiple hops, unless, of course, you have cut-through routing, which you probably don't. And even so, that's going to cost you, so it'll increase your latency.
Yep, we agree, I guess. So, would you expect ONOS to have virtualization capability.
Yes, of the physical switches.
Yes.
So, and also, so such a virtual instance can consist of the including the multiple hardware switches. And also, if we can agree on this, so maybe we have to discuss about the more detailed technical spec as well. So especially, so I'm interested in the interface between the application and the ONOS. So even though we are agree to use the OpenFlow channel between the your about instance and the our SDN application, so we have to define the flow format. For example, so we need to define the IPv4 flow mode or IPv6 flow mode and get a flow mode or something. So
I would rather try to avoid having to define specific flow mode messages for different things. If you can express it via OpenFlow, that's
Yeah, that's what
because if you have to define, because if you start defining, MPLS, something
it's the road to madness. You don't want it.
flow mod, then the whole value of using OpenFlow is lost. So it's kind of like you want to. I mean, there might be issues there. That's different. That's a larger problem of how you express the intent of the upstream controller to the
yeah. So
but I believe you can maintain.
yeah, it possible. Yeah, it sounds good. So we have to reduce the limitation between on the interface between the application and the ONOS. And ONOS is just receiving the OpenFlow message, and also, but such an OpenFlow message is on the virtual instance. So ONOS need to translate such an OpenFlow message from the virtual to the physical world.
Yeah, that's not a problem. I think this application is completely doable using OpenFlow. You shouldn't, like just echoing what Ali said, you shouldn't add extensions to OpenFlow unless there's a really incredibly good reason to do so, and some really missing feature, which if you have to implement it in straight OpenFlow, makes your application incredibly inefficient. And of course, I have some pet features that I would like to add to OpenFlow, namely data plane packet in and also sampling, which are both missing from OpenFlow. But I guess my point is you shouldn't add something to OpenFlow unless you have a really, really good reason to do so. And I don't think you do or need to. You should be able to get pretty far with existing OpenFlow and really do your application with it. And so in some sense, this application is really independent of ONOS, but it is interesting to say, well, what would it require for this to run with ONOS? But it's really just, in this case, ONOS is just acting as a big OpenFlow chassis switch. And you can imagine another virtualization system like OpenVertex could also create a big chassis switch. Also, obviously, you could have hardware, which would also be a big chassis switch.
So from my standpoint, there's a couple of elements to this, right? So some of them do align with what we're planning to do with the ONOS or what we already have, and some of them not necessarily, I guess. So that means in order for this project to be realized, some work has to be done. The question is, who's going to do that? So we do have a notion of virtual networks. However, those virtual networks today, at least the system that's being developed, or at least being incubated, I should say, is programmable only using high-level constructs like intents. And that might be actually okay. But it does not currently have, we've had no plans thus far for ONOS to act as an OpenFlow agent, essentially, on behalf of the virtualized devices. That's something that would have to be done. I definitely see value in it. The question is, where on our list of priorities that value is, and probably not top one.
Yeah, on the other hand, if you could, if IPInfusion or whoever is willing to do the initial work on this as part of this project, it's something that would be valuable to other people as well.
Absolutely, which is what I was going to bring up next. So if you want to increase the scope of your project to provide ability to essentially have ONOS act as an OpenFlow agent on behalf of these virtualized devices, great.
Yeah, so yeah, definitely. So we would like to forge this model. So and also we would like to work with you guys closely. So of course we provide here our bouncy portion control plane application as a first application of this model, and also yeah, so yeah, we can take up some work with the ONOS side as well if needed. So but yeah. Yeah, so our engineers have a little bit different background, so I'm not sure how much effort our engineer can contribute here on site. So, but yeah, so we would like to work with you guys closely. Yeah, and also based on this, we have several customers in Japan and US. So I would like to introduce such a solution to the customer as well. Yeah.
So I guess another question, which is not quite technical, but is perhaps more sort of practical or maybe a business question, depending. And I guess, but it's very important, I think, to us at ON Lab, and sort of Atrium project. So does that mean that this whole system would be open source and would be sort of freely available for us and for anybody else who wants to use it to use it? This is an open source project that you're proposing? Is that correct?
So in terms of the Vanosy, so this is our product. So it is very difficult to disclose here provide the Vanosy as an open source. So but yeah, we think about the small set of the control plane as an open source. But yeah, I need to integrate. However, so we can evaluation version of the So, but yeah, in this model, if using our Vanosy, so SDN controllers using the open can be applicable.
So I didn't quite get that, but as I understand it, you're saying VernoC is actually a closed source product that's owned by your company that you sell to people. So it seems to me that there's no way that could possibly be appropriate for inclusion in Atrium.
Well, so hold on. So I mean, as much as VernoC is a as much as VernoC is a as much as VernoC is a proprietary product.
Yes.
But in the context of this work, you should consider having an open source version of it.
Yeah, we will consider. So similar to the SDN IP solution, so we are using the voice PGP protocol. However, so the voice PGP is a commercial version supporting a lot of features. Sure. So at that time, we decided to reduce the supported features, and then decided to provide the open source version of the PGP. So similar to this, we will think about the yeah, so we will think about this.
It's good for you too, because you can show people the open source version, and if they need, infinite scale or whatever you want to call it, right? They can buy the proprietary version without an open source version. It's just it'll make us have a big virtual network.
So I'm thinking after about these features, so comparing with our product, so I can provide free version of the control application. So in this case, can play out this model by free version or
Free is not good. Free is not good.
Yeah, but
I mean,
I need to talk with to my internet to make the decision because it might have an impact on business as well.
Well, it'll make you more powerful.
Okay, so it sounds to me like this is a closed source proprietary product, which is fine. but it's something that certainly will not be part of Atrium, and certainly will not be included or provided with ONOS. It's just a proprietary app that runs on top of ONOS or is compatible with it. Is that correct?
Sorry.
I mean, I guess my understanding is that this is your own product, and people buy it, and
yes.
So it's not going to be part of like the ONF Atrium, which was all open source that people could just download and use, and it's not going to be something that we would distribute as like a supported ONOS application, because once again we wouldn't be able to distribute it. So from our perspective, it almost sort of doesn't matter. You can sort of do whatever you want, because it doesn't really affect us. But what, of course, could be part of ONOS project would be this ONOS northbound, or this OpenFlow northbound interface to the ONOS virtualization system, if you'd be able to provide that.
Yeah, I still think something like Vernos of ONOS as open source software.
Yeah.
I mean, like from that, you derive so much functionality.
Yeah. So Vernos is our commercial product supporting a lot of features. So however, so right now, it's my opinion. So I'm just thinking to follow the same approach of when we are working on the SDN IP. So after reducing the supported features, so I'm thinking to provide a Vernos Lite or something as an open source. So in this case, any guy can play out this model by using your ONOS, the Vernos Lite or something.
I mean, what is the?
That would be cool if you could make it happen.
You have the real value of Vernos, right? Is the number of protocols it speaks.
Yeah, yes, right? And also supporting the number of supporting applications.
Yeah.
There is VPNs, VPN V4, VPN V6, or something.
Yeah. I mean, I think that's where you're gonna make money.
Yeah.
Not anywhere else.
Yeah.
So if you provide a light version that supports BGP and say OSPF.
Yeah. So let's say BGP, OSPF, or some additional features. So maybe IP focusing on the IP side. Yeah.
I think we're done. Yeah.
No, thank you very much for coming. And
no problem. Yeah.
So let us know how it pans out after you talk to your internal
so
legal department.
So I'm making the plan, and then I can get the approval.
Okay.
Easier.
Sounds great.
Yeah.
Okay. Well, thank you very much.
Thank you.
Thanks everybody. Bye-bye.
Bye.